Today I'm going to tell you a little bit about my work in data visualization design. A few weeks ago, I went to this museum. It's called the Mauritshuis. It's in The Hague, where I live. And I couldn't remember the last time I visited this museum. And since it was my mother's birthday, I thought it would be a nice idea to include myself in my birthday present. And so I went there together with my mom. And it's a beautiful museum, and they have paintings primarily from 17th century, the Netherlands. So there's some real famous ones, like this one from Rembrandt. Here's one of my favorites, View on Delft by Vermeer. I guess everybody knows this one. And this one is always a little bit special to me because it's the anatomy lesson by Dr. Nicholas Tulp. Yeah, and of course you may be wondering, is he related or not? Well, my family says no, but if you look closely, I clearly can see the resemblance. But another reason why I want to show you this image is that this is also a little bit of a metaphor for, well, a little bit kind of for data visualization, because what he's doing here is he is showing something that is normally not visible to in this case, a group of other physicians. And that's also what you're doing with data visualization. This painting was made by Rembrandt when he was only 23, so you can imagine how much talent he had. But this painting was made during the scientific revolution, and it was a period when humans started to think about nature in completely different ways. And a few inventions contributed to these ideas. One invention is this. This is a microscope, and a microscope is a device that allows you to see through the lenses, and then a world that's normally unseen suddenly is brought back to within your own visual capabilities, and suddenly you can see a world that was unseen. A similar instrument, also invented in the same period, is the telescope. And with a telescope, you can not look at very small worlds, but very distant worlds. And again, what a telescope does is it brings back a world that is normally too far away within your own visual capability, so that something that's normally unseen becomes visible. Today, we live in a very complex world, and we want to understand the world. And so what we do is we collect data, but because if you compare it to a telescope or a microscope, you're actually looking at it, but sometimes things are too big or too fast or too slow or just invisible. So, and you might say that we have senses, so why not use those? Well, these work perfectly for our direct environment. We can navigate through our environment and we can interact with our environment, but once it's too big or too fast or too slow or invisible, then we need to collect data to understand the world. Now, if you think about data, you can think of something like this, taking a snapshot of the actual physical world. So this photograph of this food is not the food itself. The food, well, you can eat it, you can smell it, you can taste it, you can move it around, but this image is just a snapshot of a certain moment in time. If you consider this to be one data point, this could be considered a data set. And now you might say that this is a guy doing a backflip, but what you're actually looking at is multiple images stitched together, and we make an interpretation. And that's really what we're doing with data. We collect samples of the world, and we try to understand the world by interpreting these data points. And data visualization is one instrument that can help you do that. But when you create a data visualization, there are lots of design choices to be made. And not only design choices, but also on the data side, also on the questions that you're showing. And it's the same as this image. The photographer took a certain perspective. It has finally positioned these images, some coloring used. So there are some choices made so that you get a certain view of the data. Data can be represented in very different forms and ways. This is a data sculpture by Natalie Miebach, and she creates these data sculptures. This one is based on wind data. It's just one representation of data. Another representation of data is this, and it's from a workshop from a friend of mine, Moritz Stefaner, and he has a workshop called Data Cuisine, and together with the chef and the participants, they decide on a data set and what kind of questions they want to answer with data, and then they represent it with food. So you can eat your way through a gross national product or something. But data is most often visually represented. So now the question is, of course, why would you represent it visually? And to give you some experience of that answer, I have a very small exercise for you. What I'm going to do is I'm going to show you a set of numbers, and what I want you to do is how many times you see the number 3. And once you know the answer, just raise your hand, otherwise you would spoil it for the rest. So, how many times do you see the number 3? It's a serious assignment. If you know the answer, just raise your hand. First hand, some more. There are a few more. So what's the answer? I'm sorry? 19? 15? Well, it's quite amazing. I've done this exercise many times, and it has never happened, even with very small groups, that people have the same answer. So that's quite astonishing, I think. Of course, there's one correct answer, and I don't know what the answer is. I never counted them myself. I leave that up to you. But that's also not really my point, because if I would have shown you the data like this, you would still have to count them, but locating them would be extremely fast. In fact, our brains are very good at processing visual information. So your brain can process this information faster than you're consciously aware of it. Therefore, highlighting these elements in such a way is called pre-attentive processing. So that's one reason why visually representing data can potentially be a very good way to represent data, because we are very good as humans to process visual information. If you think of a visualization, there are always 3 main components. That's the visual design and the interaction, the concept or the questions you can ask or what the user can get out of it, and the data itself. Another way to think about this is how, why, and what. And today I want to show you examples of each of those 3 components. And remember that all these 3 components are part of every project, but it depends on the project. If you spend more time on visual design, sometimes you need a lot of data processing, but they're all there. So let's start with visual design and interaction. This was one of my first projects. It's for Nielsen, and Nielsen is a worldwide marketing intelligence organization, and they measure all things about the consumer market. And at the time when they approached me, they were busy creating a new corporate identity, and since they work with data so much, they wanted to incorporate data visualization into their corporate identity. I am a great fan of that idea. I hope more organizations would do that. So they gave me this assignment, and what they wanted to do was, the way they wanted to incorporate data visualization was that they wanted just nice looking images which they could include in their brochures and flyers and things like that. So this was the assignment they gave me: create various visualizations, but based on real data, which was actually the interesting part because, yeah, you could also say, why not generating random data? But they wanted to have it based on real data, but purely for aesthetics, so you didn't have to see what it was about. Other than that, there were no requirements, except for one, which makes sense if it's a corporate identity, the use of colors. Now, this data that they sent me was a very large Excel file. I never had an Excel file which took me 20 minutes to open. And inside this Excel file, there were 7 years of sales data for all kinds of products and brands. There were attributes of those products, so the launching date, who the brand was, things like that. But also multiple time series, 60-week time series of the pricing of the product and discounts and things like that. And there was a hierarchical structure of organizing these products in different groups. So the way we approached this project was that I would start just looking at this data and generate some images that would look nice, and then based on these various images we would decide this is the direction we want to go in, and we would then create multiple variations of that idea. So let me share with you some of those examples. This, for instance, is the hierarchy of these products. But yeah, I wrote the algorithm as well, which positions these nodes so that you don't have overlapping nodes. I didn't invent it, but it was my own implementation. And well, it really depends on what level of the hierarchy you select. So this was somewhere in the middle, two levels in the middle. But here I have the highest level, so you have a few big categories with lots of products underneath, and also the lowest level, which are the pink circles. Those are the lowest level in the hierarchy with only, so many groups with only a few products in it. And this is two very high levels. I like this one very much aesthetically. But yeah, there was much more in this data set. So this is about time series. If you don't know what you're looking at, it might look like a nice patch of colors or something. But since it's based on actual data, I can explain what it is. So every horizontal gray line is the first week of a time period. And then every column is one product. So you see a lot of products here. And I made up my own rule. So when the price becomes higher than the initial price, then the color will become blue. And if it becomes lower than the initial price, then the color will become pink or red. And then you get something like this. And here's another selection of the of a set of products. And I sorted them by overall performance of a product. So these are much cheaper than when they started. But yeah, time series can also, of course, be represented as line charts. So they're overlaid on top of each other. And here the rule is the ending price compared to the starting price determines the color. But yeah, why should you create a horizontal line chart? You can also create a radial line chart. So this is basically the same concept, except the axis is radial. And this was the image that they liked best. So my next step would be to generate multiple images or visualizations of this data in a similar way. Now you have to understand that I create custom data visualizations, and for me that means I write code. And with this code I connect to a data set, or I read in a data set, and then with my code I turn it into a visual representation. So whenever I want to have a different color for these lines, I have to go back to my code, change the color of the lines, and go back and see what the result is. And that's really a lot of work. So what I did was I created a tool for myself, and with this tool I was able to browse this data set, and with the combinations of keys and mouse movements I could select or change the size of these circles, whether I would show the marks or not, what colors I wanted to use. And yeah, I spent a full day just browsing this data set, and once I got some nice image, I would save it as a PDF, and then there was another one. So that was my process. And here are some of the results for this that finally went to the client. The funny thing is that since it's based on actual data, here you can clearly see the seasonality of some products. So some products are, well, higher priced in some periods and lower in some other period, but it's a cycle apparently. Here you can see it as well. And this one has very extreme spikes. So all these products have, or groups of products have their own kind of characteristic. And here you see how a visualization is used in a brochure. Now, when you think of visualization, you can think of different types of visualizations. And so as a kind of sidestep of these three components, I would like to explain how I personally see these different types of visualizations. Because if you look on the internet and search for a definition of data visualization or information visualization, you can find multiple definitions, and some are really strict that it really should communicate information. Some are, my personal definition is much more loose, as long as it's a visual representation of data, but the purpose can be different. So let's explore this idea of different types of visualizations. So within the field of visualization, there's a well-known kind of trade-off: explanation versus exploration. And explanatory visualizations are visualizations where you really want to communicate insight. You want to present the insights. And as a visualization designer, you are the author of the visualization itself. And usually they are also not interactive or just slightly interactive, because if you want to present something, you don't want it to be so interactive that the user drift away and what you're actually trying to communicate is getting lost. So these are non-interactive or slightly interactive. On the other hand, you have exploratory visualizations, and those are the visualizations that are highly interactive, and because you want, as a user, you want to explore a data set from different angles. You want to discover insights, not presenting insight, but discovering insight. So as a data visualization designer, you're not designing the visualization itself, but you're designing a set of tools that a user can use to, well, look at different angles to a certain data set. There's another well-known trade-off, form and function. If you are creating a very functional visualization, it means that you're designing the visualization, it has a purpose, and it needs to be very effective. So you are really trying to make sure that users understand what you're trying to communicate. On the other hand, when form becomes more important, well, maybe it's data art, and it's more kind of a way to express yourself. Now, if you put these all together, you get 4 quadrants. This is my own model, but I think it works reasonably well. So you have storytelling. These are very functional, and you try to explain something. Impression, these also present something, but form is more important, so you can get some idea out of it, like this is really big, or this is really fast, or something like that. Then you have experience, so its form is very important, but also interactive, so maybe an installation or something. And then analysis, so you can think of business intelligence tools, because those are the tools where you really want to discover insights and you want to be able to explore it from different angles. So let me give you examples of all 4 types of visualizations. This is a visualization done by the Office for Creative Research. They don't exist anymore. They were from New York, and this was a project they did for Scientific American. And what you see is the publications that have been published after the relativity theory by Einstein. But if you look closely at this visualization, you see that most of the available space is used to create those lines. And it takes up a lot of space, and at the same time, you don't really get a lot of information out of it. There are some annotations there and some there, but at the same time, you see a lot of shapes and where you don't really know what it is. So you can get some idea out of it, but apparently form is also really important. So that's what I would call a visualization that gives you an impression of a data set. If it becomes interactive and form becomes important, you might get something like this. This is done by Unformative. It's a design studio from Berlin. And they did this project for Nike, and in a Nike store they had a Kinect depth camera. And so when people were in the store and they would move in front of this camera, you would see this image also moving. You might argue that this is not really data visualization because it doesn't communicate any information. I would still argue that it is data visualization because this Kinect only provides you with digital data, and they really made design decisions and to represent this data in a certain way. They also, if it had to be more functional, they could have added maybe more small charge with the speed of motion of the arms or whatever, and then it becomes more functional. But it was really meant to be an artistic project. But to me, this is still data visualization. This example is by the New York Times, and it shows you the effect of the recession on different markets. It's online and it's also interactive, where you can explore every individual line. And so the idea was, or is, for this visualization to clearly communicate some story. It is interactive, but the only interactivity you have basically is see what every line is. So you cannot drift away to some other areas and explore the data from a completely different perspective. It's really a visualization that tells a story and also tries to do it effectively, because if it doesn't really communicate the message very well, then, well, for a newspaper, that's pretty useless, I think. And finally, this is a screenshot from a product from Cinerscope. It's a Dutch spin-off from the Eindhoven University. And they created this tool. And with this tool, you can analyze big data. And you can connect to different data sources. And for instance, insurance companies use these tools to visually explore data sets to detect fraud. So this is a data set where they didn't tell you a story, but they provided you with some tools to allow the users to visually explore a data set and look at it from different perspectives and to filter and to interactively explore it. So these are the 4 types of visualizations, and I would say any visualization can be anywhere in between, of course. Now the third component in this case is data. And so on the data side, you also make a lot of decisions. In my experience, even if the data is in a good shape and you could potentially work with it directly, you still probably have to make some restructuring and adjustments in order to visualize it. Sometimes it's very little effort, but sometimes it's really a lot of effort. This particular project is a project I did for the European Space Agency. And it's about this satellite. The satellite is called, and the mission as well, is called Hipparcos. I don't know if you saw the news a few weeks ago where the European Space Agency released a very large data set of 1.5 billion stars. That's the most recent mission they did to measure stars in the sky. This project was done maybe 25 years ago, and at that time it was the most accurate star catalog in the world. So they measured about 100,000 stars, and it was 200 times more accurate than anything that existed. And as a kind of a stepping stone to this new project for which the data was released a few weeks ago, they wanted to communicate to a general audience or a science-interested audience what is inside a star catalog, what is it? And if you look at what they have themselves right now, you can see maps like this. Of course, the data is available digitally, but also in books, a big pile of books with tables and maps like this. And so the goal was to communicate, well, kind of the essence of what a star catalog is to a general public. And so this data set had 100,000 stars, but in the end we visualized only 60,000 stars. And the reason why we filtered out a few, 40,000 stars, is because some were outside of the error ranges, some didn't have all the data that, well, I wanted to have a full data set for all the dimensions, and some of them didn't satisfy that requirement. Sometimes we had an image that was just not really captivating. So eventually we decided on a certain data set that worked well for that particular situation. And for this project, I want to show you a live demo. Let's see if that works. So this is the starting screen of the visualization. So you see the sky just moving. Then when you click start, it stops moving. And well, let me explain to you a little bit what you're looking at. On the right, you see a description of every view. Here on top, you have some suggestion of how you can interact with this visualization. Here on the left, you have some buttons or toggles that help you orient yourself a bit more. Here at the bottom, you see the steps to explain the various aspects of a star catalog. And here on top, above the buttons, you see a slider, and there's usually the main control for that particular view. What I personally think is very interesting, you can move around, and you can also zoom, and the choice for constellations is really a human choice at a certain moment in time, because if you start zooming out, you see that it's at least not related to the position of the stars, but really how we see stars from Earth. So this first view allows you to change the apparent magnitude. And the apparent magnitude is the brightness of a star as you would measure it from a certain location. So here you can change the brightness level that should be visible. The next one is absolute magnitude, and as you can see, if I switch between those, most of them become bigger, some of them become smaller. And the absolute magnitude is the brightness of stars as if they are at a fixed distance from the point where you make the measurements. So that's actually what I'm doing. So if you would zoom out now, I'm actually positioning the stars on a sphere. And here you reset them to the original position. So that explains, of course it's not reality, but it explains the concept of what or how absolute magnitude is measured. The next view is the Hertzsprung-Russell diagram. It's a view where you see temperature versus brightness, or some variations. There are several types of these diagrams. And basically, why astronomers find this diagram very interesting is because this diagram shows you something about the life cycle of stars. So whenever a star is burning its fuel, it changes position in the star. So you see a few stars here. These are white dwarfs, so these are actually stars that have died. But a long time ago, they were also in this diagram, and they moved around here, and then suddenly they ended up here, for instance. Here you can turn on the color of the stars based on the temperature. And well, if you look at the sky, you might think stars are stationary, but they actually move. So what I did was I created a simulation of how stars move in the sky. So you can move forward, and you can move backwards in time. The way this is represented is slightly different from the other views. This is a stereographic projection. It might look like the stars are moving forward and backward, but they're actually moving in a... Oh, this is a nice cluster moving here, you see. But they're actually moving in a two-dimensional space, and the size changes because the brightness changes. And you can go back to today. And finally, the final step is all the controls all together. So you can turn on the brightness completely, turn on the color, start the motion, switch between 3D or stereographic, zoom in, zoom out, star names, constellation, whatever you want. Now this way of representing or telling something about a data set is sometimes called a martini glass. Because in these areas, except for the last step, these first few steps, they have very limited interactivity, and they only explain one concept. And so just like a martini glass, the interactivity is very limited, and then it opens up, which is the final step where you can really explore a data set. But the reason why you may want to do that is because by then you have gone through every step, and so you know what you're actually looking at. How would you rate this visualization? I think you can do it quite quickly. So let me explain something about this visualization. This is a visualization that is created by Boris Muller. And Boris Muller is a professor at the University of Potsdam. He teaches data visualization. And for several years he was asked to create a visualization for the poster of the Poetry on the Road festival. So it's a festival about poems. And every year he used all the poems of the festival as a data set. So he somehow turned text into numbers in order to visualize it in such a way. And for this particular visualization, let me explain to you what you're seeing. So every circle here is one poem, and the biggest circle is the longest poem, and the one in the center is the shortest poem. Then he assigned numbers to letters. So A is 1, B is 2, C is 3, D is 4, etc. Then for every word, he summed up these numbers, and then you end up with another number. And that's, these are all the red dots on these circles. And it's a kind of a scale where 0 is on the top, and well, I don't know what the maximum number is, but it's the sum of these letters, and that is the position of these red dots. The size of these red dots is based on the number of words that have the same number, same sum. And finally, he connected all these words again in the original order of the poem. Then you get something like this. And yeah, this was, so you only see this visualization, but it was, of course, part of a poster where the festival was announced, and it was meant to trigger people to go to the festival. So now that you know a little bit more about it, who created it, what it was for, how you could read it, how would you rate it now? For who did it go up, the rating? For who did it stay the same? For who did it go down? I think most people had up, so I would consider it a success. The idea of something being interesting is, there are two components. Something needs to be novel, and you probably think of novelty when you think of something being interesting, so unexpected or surprising or taboo or something like that. But you also need to be able to understand what you're looking at. So again, if you, seems like it's a kind of a favorite representation diagram for me, but if you make all the combinations, so for instance, common and comprehensible, you can think of a bar chart. Bar charts are very common, they're very easy to understand, everybody understands them, but I personally don't get really excited about bar charts. But that doesn't mean that they are not useful. It's not without a reason that bar charts are used so much, because we are very good at seeing differences between lengths of lines. So, boring but useful. If something is new or novel, but you cannot understand it, then it can be confusing. But at the same time, it can be beautiful. The visualization I just showed you, maybe you already thought, without knowing anything about it, that's a really nice, beautiful looking visualization. So it can still be beautiful, but at the same time, you probably didn't have an idea what you were looking at before I explained it. If it's common and incomprehensible, you can think of bar charts where they are cut off halfway, or pie charts that are rotated in 3D so that the lowest segment seems bigger. And so manipulating with data, that's really a failure. And finally, when something is novel and you can understand it, it could be interesting. So the third component, the concept, or the questions you ask as a user, or what you can get out of it. And for that, I would like to show you a personal project of mine. And it's about politics. In 2012, we had national elections in the Netherlands. And, well, as soon as the results were published, everybody was asking questions. And these are completely valid questions, completely relevant. So which party has won? We have lots of political parties in the Netherlands, so you always have to make coalitions. So these are all valid questions, nothing wrong with it. But sometimes you can also ask different questions. So I had a different question, and my question was, which cities vote in a similar way? And are there maybe some patterns to be found? And that was something I was interested in exploring, so I scraped the data and started making my own visualization. And the idea of looking at the similarity, it's slightly more complex, but just to get an idea of the concept, you have two voting results. If you just overlay them and then sum up the differences, you can kind of imagine that if it's 0, then they're voted exactly the same, and if it's the bigger the number, the more different they are. It's kind of the concept. So this is the visualization. It's a map of the Netherlands, and the Netherlands is extremely populated, so I didn't actually have to draw a map. These are just the cities. You can hover over the circles, and when you click on it, they become more orange, and other circles also become more orange and bigger if they are more similar. And, well, you can see that some patterns emerge. There's another view, which is a radial view, where the selected city is in the center, and the closer the other cities are, the more similar they have voted. On the top left, you see the voting profile for the selected city, and if you hover over the other cities, you can compare that with the selected city. Then I also included another data set, the number of people living in the city, because I thought maybe there's some kind of correlation between big cities and small cities and how they vote. Yeah, so basically this is the visualization. You can also select a specific city there with the drop-down. Now the question, of course, is, are there some patterns to be found? And there definitely were. So let me share some of them with you. This, I think, is very interesting. This is a regional cluster. In the middle of this cluster there's Eindhoven, and Eindhoven is one of the larger cities of the Netherlands, but Eindhoven itself is not part of this cluster. So apparently cities around Eindhoven vote in a similar way. At the same time, it's different from Eindhoven itself, and also kind of different from the rest of the Netherlands. And I would say that this could be, well, quite interesting to explore further. Would these clusters remain the same over time, regardless of what they vote, or something like that? In the Netherlands, we have a Bible Belt. So if I select one of those cities known as being part of the Bible Belt, you see the other cities that are part of the Bible Belt. We also have a few cities in the Netherlands that are considered to be rich cities, where rich people live, and, well, they also light up. Here I've selected Amsterdam, and even though the correlation is not extremely strong, you do see that the bigger circles are more on the inside and on the outside, so bigger cities also kind of vote in a similar way. And as with many data sets, there are always outliers, and this is Urk, and there's really no city that votes like Urk. They even don't vote on certain parties, so it's quite astonishing. The final topic I would like to show you with regards to a designer making design decisions is metaphors. Because I think metaphors can be a very good way to make your visualization maybe look nicer, but also make it easier to understand. So this is a project I did for Nature magazine, and it's based on a research they did a few years ago, and it's about the total number of trees in the world. And before they did this research, they only relied on satellite images. So if they saw a certain type of vegetation, they made an estimate, this is the number of trees in this area. But what's different with this research is that they actually dispatched people to count trees. So they could make much more accurate estimates of the number of trees in the world. So do you have any idea how many trees there are? Any wild guess? No? Well, let me reveal it to you. 3.04 trillion trees. For this particular project, I created an animation. If you happen to be in Paris, there's currently an exhibition for, I think, 5 more months, and this visualization is part of that exhibition. There's beautiful work there, so if you are in Paris, you might want to check it out. So let me show you the animation.
How many trees are there in a forest? What about a country? How about in the whole world? The answer, we now know, is that our planet is home to 3.04 trillion trees. That's actually almost 8 times more than we thought, as previous estimates were only based on satellite pictures. But now, we have data not just on how much land is covered in forest, but how dense those forests are as well. Measurements were collected by thousands of people out counting trees in forests all over the world. The average density of trees at each location is represented by the height of the green lines. Some of the densest areas are these subarctic forests, where you can find a tree every square metre. But almost half of all our trees are found growing in the vast tropical and subtropical forests. All this data is going to help our understanding of where endangered species might be able to live, how water is cycled in an ecosystem, or how much carbon dioxide is being absorbed from the atmosphere. It also helps us work out what we ought to be doing to preserve and replenish our planet's forests. Because even accounting for new growth, we're currently losing about 10 billion trees a year. At the moment, there are about 400 trees for every person on Earth, but they're disappearing at a rate of 1.4 trees per person every single year. If we keep going at this rate, a walk in the woods will soon become a lot trickier. Thousands of years ago, before human civilization took hold, the Earth had almost twice as many trees as it does now. Most of Europe, for example, was one big forest. Groups all over the world are working on planting trees and restoring natural habitats. This new data will make their targets more accurate. And it will certainly change our fundamental understanding of our planet that we now know we share with 3.04 trillion trees.
So that's the visualization. And let me give you another type of behind-the-scenes look, because let me tell you a little bit about how I try to come up with this metaphor for this visualization. So first of all, this was the data set that I received, and you might say it's an image, and that's true. It was an image of 1 gigabyte. So it was an extremely high resolution image, and you could zoom in and zoom in and zoom in and zoom in. And so what these researchers have done, they have been able to make estimates of the density of trees on a square kilometer area, which is really impressive. So this was basically my data set, 2 coordinates and 1 gray value which stands for something else, and in this case it was the density of the trees. Now, I did some research on the internet of the kind of appearance that I was looking for, and this was really the kind of look that I had in mind, the rooftops of trees in a forest or a jungle where it's a little bit wobbly and that kind of appearance. My initial idea was, in order to get to something like this, I would create, well, first I had to reduce the data set because there were way too many data points for me to show. But after that I would show a transparent globe with dots, and they were displaced from the globe based on the density. And then you get something like this, and well, obviously you cannot make sense of it. So this really didn't work. And this is usually how the process goes. Initially I have some idea, and then I just get started, and well, I will see if it works visually. So here I quickly added a solid sphere inside the trees, and also used lines instead of dots. But this kind of rooftop idea, well, that was really hard to accomplish, because as you can see over there, the green is just one big area of green. And so I did a lot of experimentation with threshold levels for different density values. So, but you still see a lot of equal areas of green, maybe a fixed height, but then, well, I really actually don't know what exactly I was doing, but this was also one of the attempts. Here, different color sets, another color set. And finally, I ended up with this. And this really worked, because now you can see it's not one a single color green, but you really see these kind of rooftop appearance. And the way that I achieve this is by every line has a gradient, and it starts with the blue on at the globe, and then it ends with one of the green values. And since they have different heights because of the data value, you get this kind of rooftop appearance. And then, well, it works really nicely. This one also ended up on the cover of the magazine, which is also very nice. So with regards to metaphors, I think that if you have the possibility to use metaphors, so if your data represents something from the physical world, one idea that you could apply is to think about the properties of the physical object or thing in the world and how you can use that in your visualization. I will give you a few more examples, not by me, but this one is by the South China Morning Post, and this is about the death of soldiers in Iraq. And what they cleverly did is the chart is red, so you immediately think about blood. And I also flipped the axis, so it's really blood dripping off the chart. And so this is a perfect way of using a metaphor and really making the message much stronger. This is another example. It's, maybe you know this one, it's the wind map by Fernanda Viegas and Martin Wattenberg. It's online. And it's a near real-time representation of the wind, and you can zoom in, I think, infinitely. And what it does, you see an animation of lines going, well, following these flows, as you can see over there. And I personally think this is a very good way of using a metaphor again, because when you think of wind, it is something that is flowing and it goes to a different direction, and that's actually what you're seeing. And so if you look at, I don't know, news maps where you see wind and it's just an arrow or something like that, this one is much closer to what wind actually is. And with that, I would like to conclude that, well, with data we make an abstraction of the world, and it's just an abstraction, but it helps us understand more about our world. But you have to be aware that a visualization designer always makes decisions on the data level, on the conceptual level, the questions that you can ask, and also on the design level. So you also see the signature of the data visualizer. Thank you very much. Thank you.